in the world is the vertex? The peak. Good, that top point, or if we're opening the other way, the bottom point. So the vertex is that top point, the maximum or minimum value. You can find that in the calculator. I taught you how to do that yesterday, didn't I? And so what is the maximum? What is the vertex? What 5? 35? Someone check that in your calculator. Verify that I'm right.
That was a guess.
And you are, for some reason, plotting data like on stat plot. And oh. Okay. Is everyone getting 3, 5 for the maximum point? X equals 3, y equals 5. Anyone not know how to do that from yesterday? Second trace maximum, you go to the left of the maximum, push enter, go to the right of the maximum, then push enter. Does anyone see where that's coming from in the equation? The 3 and the 5?
Yeah.
There it is, right? So maybe we could have done that without a calculator. Maybe. But we use a calculator. It's great. Do you have a question? You sure? X-intercepts. How do you find those? Can you use a calculator to do that? How do we do that? 0 intersects the x-axis. So it would be helpful to put 0 in Y2 so that you can use your intersection button. Otherwise, you can use your zeros button. So go do that for me. Find the x-intercepts. Let me know when someone has those. What did you say? 4.581? And 4 point what? 1. Or no, 1. Okay, how did you find those? The intersections, right? Because 0 and 2. Everyone go do that. Make sure you can. Can we all do that? Raise your hand if you need my assistance to get you there to those 2 points. Okay. That's from last night's homework, isn't it? We did that last night. Y-intercept. How would we find a y-intercept? Okay, good. You could use the value button and plug in 0, or you could plug in 0 by hand. Negative 13, is that right? Just let you know, I've drawn my picture poorly.
Yeah.
I didn't curve it early enough.
It's okay.
Looks more like this, right? Okay, and so the y-intercept is 0, negative 13. You can write y equals negative 13. And you would say no y-intercept, but every quadratic will have a y-intercept. Because the range or the domain of a quadratic is all over. So I think that's all applied to 0. Which is what second trace value 0 does. You're making your calculator plug in 0 for you. Domain. What is the domain of this quadratic? And how do you know? Negative infinity to infinity, and how do you know that? It never ends. So you know it's going to take it a really long time to get very far out there, but you could plug in 1 million for x if you wanted to, couldn't you? You would get some value. I would get the domain. Well, you always start on the left and go to the right, not up and down for domain. So, okay, forget down, left and right. Do I touch the graph out here at negative infinity? So if you're telling me do I touch the graph? Do I touch the graph way out here at negative infinity? Does this keep going? The domain is out. But does it go out here? Yes. That's negative infinity. And it doesn't go out this way. So domain is what are the x values. And I have x values all the way from negative infinity. Now what you're answering is range. You're right. We won't have negative infinity on range. But it'll start at the bottom on range. Do I touch down at the bottom? With those arrows going down? Alright, so I touch always, right? So I start first, the first place I touch, and that's where you're going all the way down there, right? And that's negative infinity, so I start at negative infinity. All the way up to where? Flat 5. That's that top value where I stop. The value, the y value of the vertex is going to be involved in that domain. So everyone see that? Turns out, with a quadratic, the domain is always negative infinity to infinity. If you have a quadratic function, you can answer that quick. Domain is always negative infinity to infinity. The range is always either negative infinity to the max or the minimum to infinity, depending on if we're opening up or down. Does anyone know what an axis of symmetry is? Good. The line where it folds on itself, the line that it's symmetric with respect to. Does everyone see this little line right here? If I folded that parabola in half on that line, would it fall on itself? That's called a line of symmetry. Is that line vertical or horizontal? What's the equation of a vertical line? X equals, and what does X equal? Isn't that always going to be the X value of the vertex? Well, won't that always be the X value of the vertex? X equals the X value of the vertex. That will always be the line of symmetry. So these are some things we're going to learn today. Another word is concavity. Concavity is how does it turn? Does it open up or does it open down? Does it cave in downwards or cave in upwards? We're going to say up or down. So is this concave up or concave down? Down, it's opening down. Okay, so this is actually a lot of what we're learning how to do today. But I just want to see how much you already knew and go from there. There are 3 forms of a quadratic equation. There is standard form. We're pretty familiar with standard form, right? That's the quadratic formula stuff. Ax squared plus bx plus c is standard form. There is vertex form. That's what we're going to focus on over the next few days, is working with vertex form. And then there's factored form. You're pretty good at factored form. We know how useful factored form can be. So these are the 3 different forms of a quadratic. They all make parabolas. And so we're going to kind of learn in each form what we can find out and what that can tell us. Any questions about that? So those are quadratic equations. 3 different ways you can write them. You can write them in standard form, vertex form, or factored form. Today we're not going to rewrite or do anything like that. We're just going to learn how to work with the form they give us. What we can find out from the form they give us. Tomorrow, well, probably Friday. originally planned for tomorrow, but we'll probably look at writing in Vertex form on Friday. Any questions so far? We're going to look at each of these a little closer. You can, but we're not doing that until Friday. Yeah, so if they give you standard form, you can put it in Vertex form or Friday. We'll do that on another day. Today we're just going to find out, hey, if they give me standard form, how can I find out things from it? If they give me Vertex form, how can I find out things from it? Okay, these are some vocabulary we're going to look at. I'm going to talk about, I'm not going to actually define them here. I think we probably hit that mainly on the bell ringer, but the vertex of a parabola is the maximum or minimum value. It's this point here. X-intercept are where I cross the x-intercept, the y-intercept are where I cross the y-axis. Concavity is which way it opens. The axis of symmetry is the vertical line that runs up the middle of the parabola. This one is a big one, and you might want to write this down. Because a lot of people on the ACT and things get stumped because they don't know what the question's asking. If they ask you to find x-intercepts, zeros, or roots, they are asking you the same question. Y'all remember that on the homework? We've seen that before, but for some reason that's really hard for students to get in their brain that those all mean the same thing. That's just okay. Okay. So this equation is given in standard form. And it doesn't ask me to graph it. It doesn't ask me to do any work with it. It just says, 1, is this a quadratic function? Well, is it? We have a number x squared plus a number x plus a number, right? So yes, this is a quadratic. So question 1, answer is yes. Is it concave up or concave down? Does anyone know how you can tell that? It is concave down. How do you know? Negative where? Negative x squared. The number in front of the square is the one that's going to tell you whether that parabola is going to open down or up. And so this one is a negative, so we're going to open down. If I have a parabola that opens down, watch, look at my hands. Does that have a maximum or a minimum?
Yes.
Which one? Maximum, right? Does everyone agree that if I'm concave down, the only thing I can have is maximum? Did I have to do any work to answer all 3 of those questions? No, so that's nice. In fact, if it asked that on the ACT, you would waste your time typing it in your calculator, wouldn't you? AX squared plus BX plus C. So if it's in that format, it's a quadratic. Yes, it'll still be valid. I didn't actually find it. I just know that there is a maximum because I know it's concave down. So we got this picture here. Is that a maximum or a minimum? If it were concave up, it would have a minimum. Okay, so the first form we're going to look at is standard form, and then we're going to look at vertex form. And how we can tell some things in standard form, which you just told me some things you already know how to find in standard form. Standard form is, we're going to look at concavity from the A, right? You already told me that. If the number in front is positive, then we're concave up. If the number in front is negative, then we're concave down. In standard form, to find the axis of symmetry, there is a formula for that. Now, if you forget the formula 3 months from now, can't you graph it and find the x value of the vertex and go from there. But this is the x value of the vertex. X equals negative b over 2a. You don't have it at all. Look for it. Try to bring it to me if you can. That one right there is it. How did you know which one you missed? I actually have on this slideshow, we'll learn how to find x-intercept later, but that's actually not true. This year I did that backwards, or forward, I don't know, I did it different this year. We can find x-intercepts when we set it equal to 0 and use the quadratic formula. Or we can use the calculator. So that's actually what we spent the last 2 days learning, is how to find x-intercepts. Quadratic formula, factoring, calculator, we've got lots of options. The vertex, that formula looks really scary, doesn't it? So let me explain what that means. Negative b over 2a doesn't sound scary, does it? That gives you the x value of the vertex. How do you find y values when you have x values? If I want a y value and I have an x, how do I plug it in? Or, I answer the question. How do I find the y value?
You plug it.
You plug it in. I don't know how y'all do that. I figured that out. But when you just plug it in, that's what f of negative b over 2a means. It just means find the x value and plug it in. So that notation there in your notes, you might even put a little arrow there and say plug it in. So the f of negative b over 2a just means plug it in. Yes. Y-intercept put 0 in for x. Well, it turns out if you are in standard form, x squared plus bx plus c, won't the y-intercept always be the constant at the end? So you can kind of save yourself some time and go, oh, the 0 and the constant. So this is some things we can find in vertex form, and pretty efficiently. Some things we can find efficiently. This is not a replacement of the calculator completely. If you get on the college algebra final in May and you can't remember the vertex formula, do you go, oh, can't find the vertex? No, you put it in your calculator and find the maximum or minimum, right? So this is some ways we can work without the calculator, but don't forget you have one all the time. So don't let yourself get stumped on anything and go, oh, I can't do that. You will see when we do some word problems how it is nice to have the vertex formula. In case you can't get your window set, you can find it by hand. But we also have a calculator. The vertex form, we're going to look at what we can find in vertex form. Axis of symmetry and vertex are really, really easy in vertex form. As you can imagine, the vertex is easy to pick out in vertex form. That's why it's called vertex form. So we learned on the bell ringer that this number was the x value of the vertex and this number was the y value of the vertex. You don't notice that on the bell ringer? Notice this one is the opposite sign, so keep that in mind. So the vertex in vertex form is just hk. So if you have a function in this format, the vertex is hk, which means the axis of symmetry is x equals h. Oh, it's always x equals the x value of the vertex. X-intercepts on this type, you would solve by square roots, wouldn't you, for x-intercepts? That would be the easiest way to find x-intercepts in this format. Again, it says we'll learn this later. We already did learn that. That's what we spent the last couple days on. Concavity is exactly the same as it was the last time. This A is the exact same A from the other form. So if A is positive, we're concave up. If A is negative, we're concave down. To find a y-intercept, you have to actually put 0 in for x and solve. The y-intercept is harder to find in vertex form. Not real hard, but harder than it would be in standard form. So there are some perks to vertex form, there are some perks to standard form. Vertex form is easier to find than vertex. Standard form is easier to find. Probably solving because you can use the quadratic formula. I don't know. Some of you probably like taking square roots just as easy as quadratic formulas. You kind of have options. Is it okay if I move this down for the people at the back? Top. Is it hot in here?
Yeah.
One of you put that.
Thank you, Braden.
I don't know if it was hot. It was stuff. It's too stagnant in here too long. Building.
Are you trying to say something about it? About that?
The building was probably built on.
No, it's on.
Oh, yeah.
Okay. This is a question you're going to have on your homework tonight, and this is a pretty tough question. So this is the next two slides are the hard stuff of the day. Use vertex form to write the equation of the graph. Now, what's easy to pick out in vertex form? The vertex. That I can do, and so that part of vertex form will be pretty easy. The vertex on this one looks to be -1/8. Does everyone agree?
Yes.
So that part's pretty easy. I'm going to write the equation in vertex form. What I don't know is A, so I'm going to leave A. I don't know what it is, so we'll hold off on A for just a second. Okay. Vertex form is A times X minus H. Isn't H the X value of the vertex? Which we said was -1. So it's minus -1, which is +1. Always the opposite sign of the X value of the vertex. Okay. Plus A. Good. Everyone see how we got there so far? The Y value of the vertex. So if I slide back one slide, this is the X value of the vertex. Okay, so HK right here. Minus H plus K. Okay. So I'm just going to follow that formula. H is -1. So what's minus -1?
Oh.
Plus 1. Just plus K is just 1. So I'm just plugging into that formula. On the X is always opposite sign. Later when we talk about transformations, you're probably well aware of. That'll make a little more sense by the time. Transformations.
Oh, yeah.
But you don't have to know that's pretty good. Alright. What I don't know is A. This is the hard slide of the day. Still not horrible, but this is the hard slide of the day. I need to find A. And I don't know A. But what I do know is I can find another point on the parabola. Any other point. So you find one for me. 0.6. I like 0.6. Everyone see where she got 0.6. Is that the only option? And I think you those points. You just want to pick one that is on a nice, like don't pick 2.5, right? That would not be fun. So pick a point that's easy to see. So I'm picking the point 0, 6. Everyone see how we got that? Okay. I'm going to put 0 and 4. What is a point? What's the first part of a point? X. What's the second part of a point? So I'm going to put 0 for X and 6 and for Y. I'm going to solve my A. So everyone see how I'm going to do that? So I'm going to put 0 in for X and 6 in for Y. So the X point that they come with 0 and the Y point they come with 6. So we're going to put that in for 0. You can pick any point on the any point will help you find A. Subtract 8 over from both sides. So I get -2 equals A plus 1 squared. What is 0 plus 1?
1.
And what is 1 squared? And I can divide by 1 to get A by itself. So what is A? -2. So my equation, which is really what I was trying to write, is -2 times x plus 1 squared plus 8. Stop at this point and check your graph and see if it falls in the right spot. See if the y-intercept's correct. Does -2 make sense for this parabola to have a negative?
Yeah.
Yes, so when I solved it, it did a really good job of giving me all of the correct information. It would be the same answer. Yeah. So if we had, Michael was saying I'm going to use -6. If I had used -6, we would have gotten the exact same answer. Any questions? Okay, let's try this one. Before I start this one, what should A end up being?
Positive.
It should end up being positive. We hope it is. Hopefully our word is to say positive. What's the first thing I'm going to pick out? The vertex. Which is? Sorry. -1, -4. So what's the beginning piece of my equation at vertex 4? A, I don't know what it is, so I'll just leave it as A for now. Minus -1, right? Which gives me a plus, so that X part is always going to be a sign change. Don't forget to square up here. A lot of times people forget to write that. It is a quadratic, so that would be squared. -4. So the Y value stays, the X value is opposite. Any questions about that? What do I need to find? Another point. And so let's see if we have a pretty one. -4, -1. Perfect. And then do you see why she picked that one? The only other one I would say, yeah, you could pick that is 2, -1. I don't see any other options on this parabola because none of them fall in a pretty spot. I don't want to use decimals. I don't want to use fractions. That would be more complicated. So I want to pick something that's pretty. And you can't use the vertex again. Okay, so I'm -4, -1. So -1 is the Y value. -4 was the X value. Any questions so far? Let's see where she got that information. Add the 4 over. So I get 3 equals A, and I am going to go ahead and simplify this. -4 plus 1 is -3. 3 gives you that positive value. So I get 3 equals A times 9. I want to get A by itself, so divided by 9. So I get 1/3 equals A. What was the vertex form? -4. Was it +1 or -1? +1. So we're going to rewrite the equation just now with the A that we found selected. We're just going to go back to the original and just put the A in. Any questions about that one? Same exact question, different mode of information. And this time they give me a table of values. Right? Could I have made a table of values from the graph? Can I make a graph from the table of values? It's really the same question, but it doesn't hurt to graph it really good to kind of see where things are falling. So -1, 13. 0, -2. 1, -7. Oh, what did I just find by graphing that really quick? I found the vertex. Does everyone agree? Where is the vertex? That is the vertex. And so now this is a problem just like on the last slide. I will tell you though, I'm going to do this by hand, showing you how to do this by hand. Do you think your stat regression would run a quadratic regression? Could you probably put the data in L1 and L2 and run a quad reg and get it to give you the parabola? So I want to mention that. I'm not going to show you how to do that again because you do technically know how to do that. You just put quad reg instead of QA. So it could give you the equation. It would give it to you in standard form instead of vertex form. But either way, you could find the A, which is probably really what you need to know, right? But anyway, so x minus 1 squared minus 7. Does everyone agree? I think we have time else to do that also. Good so far? Any questions on how I knew that part? Find the vertex, put it in vertex form. I need to know the A, so what do I need to do? Pick any point except the vertex. So I'm not going to pick that one, but pick any other point, plug it in for x and y. So what 0, -2, you want to pick that since it's pretty small numbers. -2 equals A times 0 minus 1 squared minus 7. Any questions so far? Add the 7 over. Am I going too fast? Add the 7 over. We have 5 equals A times what is -1 squared? So A is 5. So I get Y equals 5 times x minus 1 squared minus 7. Or if you got stuck on finding A or something like that, you can use it. And tomorrow I'm going to show you how to write in vertex form from standard form. Not tomorrow, Friday. So you could use the equation to get the standard form equation and then write it in vertex form. You don't know how to do that yet. Do you want to see another one? You would have to graph it. What's the point of graphing it? To find a vertex, so you can see the parabola shape, find a vertex. Does everyone agree we don't need to see another one of these by hand? Those 3 got it? Okay. Let me show you the calculator, what it can and what it can't do. It can do some helpful things. You might want to follow along with me because it's been a while since we've used our stat button, but it is also a good reminder of how to do that. If you will, go to stat and edit and type in the data in L1 and L2. I'm going to move my calculator out of the way so you can see the data. We'll do number 2 in the calculator. I'll show you how that could work. 3, 4, 5, 6, and 7. Okay. Go to stat, over to calculate, and go down to quadreg. We've never used quadreg before, so this is new to you. We have used linear regression quite often. L1, L2, push calculate. And look, it gives you A, B, and C. However, what format did it give you the answer in? Standard form. If I want the vertex form, I'll have to do a little work, but I'm going to write this down. -3, 24, plus 43 or minus 43?
Plus. Sure. Negative.
What you really learned from this is that A is -3. Okay, that's really the big thing for this, and then you can quickly draw. It doesn't even take you very many points. 3, 2, 4, 5. Well, you could even. Couldn't you even graph this in your calculator and go find the maximum? Go find the vertex. So we could even do it that way. We'll talk about that on another day. Would you agree that this is the vertex? So at 4, 5.
Yeah.
So y equals -3 times x minus 4 squared plus 5. So if you get stumped and want to use your calculator to help you, that's how it can help you on a table with that. Any questions about that?
Were we just supposed to find like the vertex in it?
We were supposed to write the equation.
Oh.
It was actually the same question. I just decided to show you with the calculator what a calculator can do and what it doesn't do.